Hello there. I am going to show you a problem, and I'm going to show you how to solve it two different ways. Both use Python, but one of them is a numerical calculation. Okay, so here's the problem. I just made this up. Here's a car, and it's accelerating. It starts from rest, and it has an acceleration of 2 meters per second squared. And the question says, how far does it travel after 5 seconds? Okay, so I'm going to go over this part quick because it's not important for what I want to show. So I start with the definition of average acceleration, change in velocity over change in time. That's the final velocity minus the initial. This one's 0 over delta t. And I know delta t. So actually, I could just go ahead and solve v2 if you want. It doesn't really matter. But this is the v2. If I algebraically solve it, is equal to v1 plus a delta t, and v1 0, but that's fine. Then I can use the definition of average velocity. Average velocity is the change in position. This is all in one dimension, if you haven't noticed, over time, change in time. It's also equal to the initial velocity plus the final velocity over 2. So if I take this v2 and put it in here, and I have v1, have another v1, I'm going to get 1/2 a, and then I got that delta t. I'm going to get this. The change in position is 1/2 a delta t squared, which you probably could have used from another equation, but that's fine. So that's what I have right here. So I'm going to now calculate this in Python, and I'm going to switch to my trinket. So this is online Python. So I've already named it and stuff. So let's just put, let's do this like x equals 0, v equals 0, v1 equals 0, a equals 2, dt equals 5. And then I'm going to say, you could even calculate v2 if you wanted to. Yeah, let's do that. No, let's not. Let's just say x2 equals x1 plus v1, well, plus 0.5 times a times dt squared. Remember, squared in Python, star, star. Let's make this a little bigger. And then I'm going to say print the final position equals x2 meters. Oops. Meters. That's it. Okay, now, and you could have it more complicated than that. Now I'm going to run it. And I made an error. x1 is not defined. x1. Sorry. Okay, boom. That's it. This is using Python as a calculator, which is super useful, and you should do it. Okay, because I can change, oh, now x1 is 0.8, and I can rerun it. Okay, that's cool. I like that. Let's go back to 0. And run it again. Okay, I'm happy. But this is not a numerical calculation. A numerical calculation takes this problem and breaks into many small steps. So let's make this a numerical calculation. So in each step, I want to calculate the acceleration. I want to use the acceleration to update the velocity. I want to use the velocity to update the position. So now I'm going to change this to just x and v, and dt is going to be not dt, it's going to be t equals 0, dt equals 0.1. It's going to be, let's say, 0.2. That's fine. And I get rid of this. And I'm going to say while t is less than 5, do the following. So each time I'm going to calculate the acceleration. A equals 2. All right, that's dumb in this case, but I did it anyway. Next, I'm going to update the velocity. So if I say v equals v plus a times dt, this we talked about before. This is the definition of average acceleration, and this is not an equation. This says a make equal to, so that's why I have v and v on both sides. But I don't want to go into that too much detail. I've already done that. And then I can update the position, x equals x plus v times dt, and I can update time, t equals t plus dt. And then if you want, you could print out something like x equals comma x comma meter space comma t, oh no, t equals t seconds. And that's going to print out the x and t each time. Let's go ahead and run that. I guess I should save it. Run it. And boom. You see here, every single step, it calculated the position and the time, and we get all the way up here to 5 seconds, and we get the same. We actually get a larger distance because it did it one more time. If I put this at the beginning, it'll give me the right answer. like that. Oh wait, that's not, okay, well it doesn't matter. That's not the point. And in fact, I could just print out the, do this at the end, and it'd print out the final time, not every single time. Okay, just like that. And if I can make the time interval small, and it'll do it a whole bunch of times, and it'll give a better answer. But this is numerical calculation. This is taking that problem, that same problem, and breaking it into all these little pieces. And it's actually cheating, and that's why we don't get the same answer, but that's a different story. This is important. And you don't even have to do a while loop. You could do it individually 8 times. That's a numerical calculation. Using Python as a calculator is not a numerical calculation, although it is indeed cool. Okay, so when you create a numerical calculation, make sure it's breaking it into small parts, not just using a calculation. Okay, the end. Hopefully that will help.